Okay, lesson 11.6, part 2. What we did yesterday was we found out how to get common denominators of problems with numbers and variables, but we didn't actually add or subtract any fractions. We just got the common denominators. So now what we're going to do is we are going to get the common denominators as well as add and subtract the fractions. So I looked at the first problem that I have here. Now I have 6x and 8x squared. Before I do anything, I want to see what type of problem it is. Is it an addition or a subtraction problem? It's a subtraction. So what I'm going to do is I'm going to go ahead and change the signs of everything in the numerator only. I do not touch the sign of 8x squared, okay? That way I don't have to worry about it. I know that it's done. When it comes time to get common denominators, I multiply, everything's ready to go. Okay? So if you remember, what we're going to do is we're going to do our factor boxes. So 6 is 2 and 3. So we have 2 times 3, and then we have an x in there. And now I have 8, so I'm going to do upside down division of 8, 2, 4, 2 and 2. So I put the things that line up together. And this is supposed to be 6x also. Then 2. So 2 gets its own box, 2 gets its own box. Then x and x. So I'm going to bring down everything that they have in common. Well, I'm sorry, everything total. So 2 times 3 times 2 times 2 times x times x. So what I'm going to have is 2 times 3 times 2 times 2 is 24 x squared. So this is my common denominator now. So this is where we've got to actually, this is not our answer here. This is what I need to make each one of these fractions. So y'all remember example 2 yesterday when we figured out, okay, if 6x, I'm going to erase all this here. If 6x needs to become 24x squared, what do I need to multiply by 6 to make it 24? 4. And x needs to become x squared, so I multiply by x. So whatever I do on the bottom, I must do on the top. Okay? We're not multiplying by 24x squared. 24x squared is the end goal. That's what I want my denominator to be. So what I like to do is I like to go ahead and write 24x squared underneath it. Now I ask myself the same question about 8. What do I need to multiply by 8 to make it 24? 3. And then x squared to become x squared. Well, nothing, because it already is. So I'm going to multiply everything in the numerator by that also. So what I'm going to do now is I'm going to combine these numerators into one single problem. So 4x times 7 is 28x. 3 times negative x is negative 3x. 3 times negative 1 is negative 3. So I just put them all, because they're all going to be over the same denominator, so we just write them like this, and then it's much easier to see what the like terms are so that I can combine them. 28 minus 3 is 25x minus 3 over 24x squared. So this is my final answer here, because I know that 25x minus 3 is a family, and there's no common denominator there that can be, I'm sorry, there's no greatest common factor there that can be taken out. So let's look at the next one, x and x squared. First of all, it's an addition problem, so I don't need to change any signs. So if I make factor boxes here for x, I'm just going to have an x. For x squared, it's going to be x times x. Bring them both down. X times x is x squared. So my common denominator needs to be x squared. Now, if you can look at that and you know that that's what your common denominator needs to be, you don't have to do factor boxes. Okay, that's just an easy way to visualize it. So what do I need to multiply by x to make it x squared? X. And do I need to multiply anything by x squared to make it x squared? Nope. So I've got 2x plus 1 minus 2x. So again, I just wrote it all in one problem. Now let's combine like terms. 2x minus 2x, that's going to be 0. So I'm going to have 1 over x squared as my final answer. Just like that. Okay, let's do some more. So I look first of all, and it's a subtraction problem. So what I want to do is I want to go ahead and change my signs. -4, -x, addition. That way it's over with, it's done, I don't need to worry about it. Now let's do my factors of 20. 2, 10, 2, and 5. Then my x, let's do the factors of 16. 2, 8, 2, 4, 2, and 2. And then x times x. I'm going to plug in my numbers, and I have 2, 2, 5, and x. And then I've got 2, 2, 2, and 2, x, and x. So I bring down everything. 2 times 2 times 5 times 2 times 2. X times x. So my common denominator is going to be 80x squared. 80x squared, okay? So now I've got to ask myself, I'm going to erase all this here. I did not mean to erase our signs here, so let me change that back. It was -4, -x with a plus sign. What do I need to multiply by 20 to make it 80? 4. And what do I need to multiply by x to make it x squared? X. So multiply the top by 4x. What do I need to multiply by 16 to make it 80? So if you're ever not positive, just do 80 divided by 16, and it'll tell you exactly what number to multiply by. 5. What do I need to multiply by x squared to make it x squared? Nothing. So I'm going to multiply both of these terms up top by 5. So I'm going to rewrite it with my common denominator, 80x squared. 12x is my new first numerator, minus 20 minus 5x. So now we're going to combine like terms. 12 minus 5 is 7x, minus 20, because 20 does not have any like terms, over 80x squared. So I notice that there's no GCF of 7x minus 20, so this is my final answer. So the last one that we're going to do is a little trickier because it's a family. Okay, y'all remember dealing with families? And families aren't broken down by prime factors. So when you have a family, this is what you do. First of all, you ask yourself, can I multiply anything by one of them to make it identical to the other? Here's what the most common mistake is that I see by people. Is I go, oh yeah, just multiply this one by 4. But then I'm going to get 4x minus 4. Does that match up? No, it doesn't. So if I look and I notice I have families and there's nothing I can do to multiply to make them the same, I just multiply them by each other. So I'm going to multiply this one by x minus 1 and everything by x minus 1. I'm going to multiply this one by x plus 4 and then as well as the top by x plus 4. So my common denominator is going to be x minus 1 times x plus 4. Now, it doesn't matter if you write x plus 4 times x minus 1, either way. But look what's going to happen here. When I multiply, I've got two families up top, so what do you think I need to do? FOIL. X times x is x squared minus 3x minus 1x plus 3. I need to make my fraction bar longer. Now the other side, what I'm going to do is I'm just going to distribute this 6. So plus 6x plus 24. So that's a big one. So what we're going to do is we're just going to combine like terms. So x squared stays x squared. 3x minus 1x is negative 4x plus 6x is positive 2x. 3 plus 4 is 27 over x minus 1 times x plus 4. Now, because I see three terms, I'm going to check to see if I can factor it. So 2 and 27, but what are the factors of 27? 1 times 27. It's a prime number. Did either of those add to give me 2? No, not at all. So this cannot be factored, and this is now my final answer. Okay, so that's what happens when we have families in our denominator. So this is the homework for part 2 of lesson 11.6. Go ahead and get started on that.